Okay, everybody, this is our day 2 for 8-7 continued, right? So we started the day 2 notes yesterday. So day 2 and a little bit more here. We're going to finish up the multiplying and then do the dividing. So it lines up nicely with the Math Excel that you guys will be doing tonight. So yesterday in your notes, we did A and B. So we talked about multiplication. So we ended there. So I want to start off with C and D then. So if you can find example 6, we're going to start off with C and D, and then we'll go into dividing. So we just have 4 examples to talk about. All right, so for letter C, I know we just hinted at this. We've talked about it before many times, though. If you're squaring a binomial, that means you're multiplying that binomial times itself. So don't forget that that means that we're going to be double distribute here. We're going to be doing FOIL. We're going to be multiplying that 3 times everything in that second set of parentheses. And then we're going to also be multiplying the 2i times all of those in that second parentheses. So we want to make sure that we have both of them there, so we understand what's happening, so we can do that multiplication. So we'll make sure that we do that double distribute so we can see what's happening. So first one, then we're going to do 3 times 3, so that's going to give us a 9, and then the 3 times the 2i would be plus 6i. And then just to kind of color code here, now we're going to do the same thing with the 2. So we've got a 2i times 3, which is another 6i, and then a 2i times 2i, which is a plus 4i squared. And just like we talked about yesterday, we're really just putting together like terms, but the idea, because it's an I squared, or i's, we might be able to do a little bit more. So let's just think about what makes sense to put together all of our terms that are imaginary. So we have a 6i and a 6i, so that would be a 12i. We have a 9 still. And then let's talk about this 4i squared. Remember what I squared is equal to. So I squared is the same as -1. So that really means we're taking a 4 times a -1. So 4 times -1 would be a -4. I know we talked too about it, just really changes the sign of that term. But what that allows us to do then is we can actually combine then our real number components, our real number parts. So we have 9 minus 4, so that would be 5 plus 12i. So when we look at doing distributive property and putting like terms together, really it's the same as what you would do in any other algebra scenario. It's just that we have this extra, oh, I squared is -1. I know I can do something with that. All right, so let's take a look at letter D. You're going to find a very similar thing here, but I'm curious if you remember what we talked about yesterday. If you take a look at those two, they're the same exact binomial, just opposite signs. So some really interesting things happen when we do our distributive property. So I'm going to do the same kind of color coding here. That means we're going to double distribute. We're going to multiply the 4 times 4, and then the 4 times the 7i. So that would be 28i. Then for the second part, we're going to be multiplying the -7i times the 4, so -28i. And then we have minus, careful with a sign there, negative times a positive, so minus 7 times 7, 49, and then I times I to the second. Now we have a really similar kind of strategy here, right? We're going to put together our like terms, our things that are the same. So we can put together the i's, but watch what happens now. We have a positive 28 and -28. Adds to 0. So that always happened. That was that difference of squares that we talked about. So all that's really left in the first part there is just the 16, because that together would be 0. So we have 16 minus this 49i squared. But again, remember what 40 or what I squared is. I squared we can replace with -1. So it's really -49 times -1, which would be a plus 49. So we actually can put that first and last term together, and when we add them together, we get 65. So when you multiply together a imaginary complex number times the exact same thing but with the opposite sign, notice we get a whole number answer. That's called the conjugate, by the way, those two terms where they're exactly the same but just opposite sign. What always happens then is that inside and outside term added to 0, so we were able to get a nice whole number, which is exactly what the skill is we're going to need when we get into dividing, which is next. So multiplying, we're doing distributive property. Dividing, really, we have to try to deal with rationalizing numbers, so making it a little bit easier to deal with. So we're going to do some dividing. If you take a look at the denominator here, we have 4 minus 3i. I is a radical, right? Technically, I contains a square root. That's a square root of -1. Really hard to to work with, that quotient there is really challenging to deal with. So what we're going to do is this idea that we just had in letter D of our last example. We're going to multiply something to make that denominator be a nice number like the 65 was. So if you looked at what we did, we multiplied the same exact binomial, just opposite sign. That gave us a nice whole number in the bottom. That's exactly what we need to do here then. So if I have a 4 minus 3i in the denominator, what if I multiplied by 4 plus 3i? Think about what would happen. Those inside and outside terms will add to 0, and you're going to end up with a really nice value, a nice number. So this is like a rationalize the denominator kind of situation. So just like we were doing with radicals before, we want to rationalize the denominator. That means make it a nice rational number. So we're looking at being able to find denominator. Can't spell and talk at the same time here. We're looking to make it be a nice whole number that we're going to be able to work with if we're going to do other operations. So to do that, in this case, if it's a binomial, we're going to multiply by what we call the conjugate. So multiply by the same exact factor, just opposite sign. So that's called the conjugate. So it's a binomial. That means if you have like a plus bi, the conjugate would be a minus bi. So same terms, just opposite sign. Because again, what that's going to allow us to do is have a nice whole number in the bottom. Now, you can't just multiply by that in the bottom though, right? Because that would change the entire value of your fraction. You need to multiply by something equivalent to 1, kind of like getting a common denominator. So we're going to multiply by that 4 plus 3i in the top as well. So this just means a whole lot of distributive property. So we're going to do what we did before. So we're going to multiply first. That would be 24. Outsides, 18i. Insides would be 8i. And then last would be plus 6i squared. So again, we're multiplying and just doing that double distribute. Denominator, we can do the same thing. First, that's going to give us a 16. Outsides, we get a 12i. Insides, we get a negative 12i. And then last, we get a minus 9i squared. So all of our work from here on out is just simplifying and putting together some like terms. This is called rationalizing the denominator. All right, so let's see if we can simplify a little bit and put some things together. Let's look at the numerator first. So we have an 18i and an 8i. So 18 plus 8, that would give you 26i. We had a 24. And then we have this plus 6i squared business. Let's talk about that. Remember what I squared is. Every time we see an I squared, that's a negative 1. So really what that term is 6 times negative 1. Well, 6 times negative 1 is negative 6. So I'm going to be able to put together some more things in the numerator then. So I have a negative 6 that I can combine with the 24 to give me a final numerator then of 18 plus 26i. And again, we're going to stick with this, write the real or the whole number real part first and then the imaginary part. It's a little bit easier to deal with. All right, let's look at the denominator, do the same thing. Look what happens though in the insides and outsides. Those 12i terms add to 0. Gone, nothing left for imaginary there. And then all we have is the 16 and this minus 9i squared. But again, I squared is negative 1. So negative 9 times negative 1. Just changes the sign. So negative times a negative would be a plus, and we end up with a 25 on the bottom. So the wonderful thing about what we just accomplished is that we now have a nice number in that denominator that we can work with. So you can either leave your answer exactly as you have it right here, so 18 plus 26i over 25, or some people like to separate out the real part. So think of that first fraction, so 18 divided by 25, and then plus the imaginary part, so 26 25ths times I. That would be the exact same answer. So you really do have the option. We can write it either way. All right, the last one that we're going to do is we're going to talk about how do you rationalize when it's just a monomial in the bottom or just something like an I. So this one's actually a lot easier to deal with. So when you're looking at something like letter B, we don't have that conjugate, that binomial going on. The only thing we have in the bottom that's really not that great to deal with is just an I, because remember I is equal to the square root of negative 1. So this is the equivalent of having a radical in the denominator. So to deal with that, it's going to be really similar to doing something like, oh, let's take a look look at an example so you can see, what if I had 3 over square root of 7? I don't like having that square root of 7 in the denominator because it makes it hard to work with. So I multiply by whatever I need to make that a perfect square and be able to get a whole number in the bottom. So I would multiply top and bottom by square root of 7 to make that happen, because what's square root of 7 times square root of 7? That's square root of 49, which is 7. In other words, if you multiply a radical times itself, you always get the number underneath, which makes this then a much easier fraction to deal with. Who really cares what's happening in the top there? It's 3 root 7, great. The idea is we got rid of that square root in the bottom. Well, that's exactly what we need to do here. So in this situation, remember, I is the square root of negative 1. So if I multiply it by itself, then I'm going to be able to see what that value is looking like, so I can actually solve for those numbers. So we're going to multiply top and bottom by I. So in the denominator, that gives us an I squared. And then in the numerator, I'm going to go ahead and multiply that through. So that would be 5I minus I squared. And then we just have to simplify whatever we need to here. So we're going to simplify down everything that we can. So anything that's an I squared, that's a negative 1. So that's going to be a negative 1 as well. And then we have a minus out front. So if we're subtracting a negative 1, that means it's the same as adding a positive, and we can put that together. So the simplifying is just us being able to say, okay, what work can I do to make this a little bit easier? So minus an I squared minus a negative 1, so that would be plus 1. Subtracting a negative changes the sign. 5I, that's fine. And then we just have this negative 1 in the denominator. So the numerator I distributed through. See, what happened in the denominator is I ended up getting a whole number, which is great. That's what we wanted to do. When we rationalize, we want to make it a little bit easier for ourselves. I think the last thing I would do then is simplify and divide by that negative 1. I can take each of these numerator terms and divide it by negative 1 and get a nice simplified answer. So 5I divided by negative 1, and then 1 divided by negative 1. I know most of you just do that in your head, but we'll simplify that out. So that means both of those terms in the numerator end up negative. So we'd have a negative 5I and then minus 1. I would probably write my final answer then with the imaginary part second. So for me, it might be a little bit easier just to say it this way. Real part first, and then the imaginary or the complex part second. So that's rationalizing. So dividing is really a matter of just getting the radical out of the denominator. So either if it's a binomial, by multiplying by the conjugate, remember that was the same expression, just opposite sign. And then in the middle, and then for the one that just has a radical in the bottom, it's just like having a regular square root down there, an I, we multiply by I to undo that term. So that's multiplying and dividing. So hopefully that will help you work through what you need to on your day 2, or actually day 3. Sorry, I'm going to get down to the right slide here so you can see it. Oh my goodness, this thing is not lined up. Here we go. So it's going to be the Math Excel for day 3. So that's your assignment. On Monday, this is not accurate for what we're going to do. On Monday, we're going to be doing the review worksheet, and the test will be on Tuesday. So that's the plan. That's where we're at for right now. So give those day 3 Math Excel, so that's the second Math Excel assignment, a try, and finish up the first day if you haven't finished up that one. There's several people that still needed to finish that up, so we will pull that all together. Make sure you use your notes. So look at the examples when you're doing the Math Excel so you can find something that looks similar, and then we'll be ready to do the review together on Monday.